Hi everyone, this is Mr. Kier. We're going to be reviewing today's position time graph quiz. I just want to go over some of the key details from the quiz today to make sure that you're really going to be good for the assessment later on. So the first thing we want to go through is just a couple of the basic ideas behind a position time graph. For example, the reference point's located at 0. Anything above here is west is going to be positive. Anything negative going towards the negative is going to be going east. We also had a few questions about the initial position of the object. So the object started at 0, so that's at the reference point. And then the object traveled all the way down here. So the final position would be -10 east or 10 meters west of the reference point. Now, you had a couple other questions associated with this, and those were the overall displacement. Now, for the overall displacement, it's from the initial position to the final position. So this would be like the dr, the resultant. And you notice we traveled or ended up 10 meters west of where we started. So it'd be 10 meters to the west, or sorry, east, pardon me. It should be to the east, or -10 west. And then for the distance, how far we traveled distance-wise, what you do is you take a look at how far the object traveled one way for one component of the trip. So we went 22.5 meters. Then we traveled another 22.5 meters. We ended up at the reference point. And finally, we traveled another 10 meters. So the total distance would be 22.5 meters plus 22.5 meters, and then another 10 meters, which gives us a total of 45 meters. So just make sure you've got the correct format when you're working on this. Okay. And we just want to make sure that you have these questions in the correct format on your worksheet or your quiz. So make sure you use the correct symbol. So initial position DI, final position DF, overall displacement delta D with the arrow on top, and finally D, no arrow for the distance. Just double checking. Okay, I also want to quickly review the instantaneous velocity. And remember, the way you find instantaneous velocity is by finding a tangent line and then finding the slope of the tangent line. So what we did is we drew a tangent to this curve at 2.5 seconds, just over here at 2.5 seconds. And remember, a tangent line has nice even spacing, even distance on either side between the line of best, so the graph and the tangent line. So this is a nice tangent. Then you pick your 2 points. I decide to pick this point here. So 1.8 seconds and 0 meters. And there's a great one over here where at 6 seconds we're at 17.5 meters. So those are my points. Now remember to have lots of space between these two between these 2 points when you're doing the slope calculation and to indicate the coordinates. Now over here at the side, make sure you use the y2 minus y1 over x2 minus x1 format. So here, the second data point is up here, so it'll be 17.5 minus 0 all over 6 seconds minus 1.8 seconds. You do the math, you end up with 4.2 meters per second to the west. So this represents the approximate velocity at this point right here at 2.5 seconds. We're also going to be reviewing the description of the graph here, the different types of motion in each component. So let's look at position of the first component here, section A. Now section A, what's happening? We're at rest at the beginning and then we're going accelerating towards the west. So the slope is increasing towards the west. So we write down accelerating westward from rest. That'll be a very good description here. Okay. Here we have a nice constant slope, and constant slope means a constant velocity. So we've got a constant westward velocity for this component. Now the next one's a little tricky. We're slowing down. We know we're slowing down because the slope is actually leveling off. So the way you describe this is you want to write down what you're doing at the beginning. So we're moving up here westward. So we're moving westward. And then we're coming to a stop. How are we stopping? We're accelerating. So we're accelerating, and we're accelerating in the opposite direction. So accelerating eastward to a stop. Then for D, we are at the same position. We're not changing. The slope is 0, so this would be motionless. And now the slope is actually increasing, but the negative direction, which would be towards the east. So here we're accelerating eastward from rest. And then we have a nice constant slope here. So we have a nice constant velocity. This time the velocity is in the east direction. So velocity. And the last little section here is we are now coming to a stop. We're leveling off. So what's happening is we're moving eastward. So moving eastward. And we are stopping, so we have to be accelerating in the opposite direction. So accelerating westward to a stop, or to rest would be okay. So just make sure that you do have these nice descriptions on your quiz. They should look something like this. Let me bring it up for you. So practice a little bit. If you need a little bit more practice, see me. I can come up with some new worksheets for you as well. That's it for this quick review of the quiz. Take care. Bye. Bye.